Before we go to lecture 2, there was one other topic I wanted to discuss on lecture 1. So I'm going to see if I still have that PowerPoint up here. And this upwind and quick. Yeah. Okay. Let's talk a little bit. Remember, okay, here we go again. Remember that a cell only knows its neighbors. So what you have to do, there's a really key critical file called a map file. And we're going to take a look, at this map file. Try this one. Okay. So let's look at this. I'll move this into the center a little bit. Let's look at this one right here. This is a map file for that 30 box model that you've got. So what you see is the face. And the face goes from 1 to the total number of faces, both longitudinal, lateral, and also vertical. They're just sequentially numbered. You've got something called a flow direction. The flow directions are 1, 2, 3, longitudinal, lateral, and vertical. So this is a two-dimensional model, so you've only got either longitudinal flows or vertical flows. And here's the key, the things you need to look at. Remember what I said was that for any face, actually I may want the one with quickest for a moment. Let's look at quickest for a minute. Remember that I said for any face, you needed to specify 4 boxes. You needed 2 boxes to the left and 2 boxes to the right. That's so you could fit this parabola. So for this face, you need to know this box, and this box. Now suppose it's a tidal system and the flow reverses, then you would need to know this box, and this box. So for any face, you need to know 4 boxes, okay? 2 boxes to the left, 1 box to the left, 1 box to the right, 2 boxes to the right. And if we look at this thing, this is a map file, who they are. Here's your face. Face 1, left, well, blame Tom Cole for this, but this is I left, I, J, and J right. Those are the 4 boxes. Now, just for curiosity, here's cell 9, and there are 4 boxes, 7, 8, 9, 10, okay? So we know that face 9, 7, 8, 9, 10 are the 4 boxes if we want to use quickest. Did you have a question, Jim?
Yeah, I have a dumb question probably. Why does it need to know whether you're the X or Y direction?
I don't think it does.
Oh, okay. All right.
There it is,
okay.
You know. Okay, now, but here, wait a minute, let's look at face 1. I left is 0, I is 0, right, 1, 2. This feature of the map file identifies boundary faces. So what I'm seeing, and I don't know if this is worth PowerPoint or if I draw it on the board, but we'll try PowerPoint for a minute. Yeah. What I'm seeing is for that face here, there are boxes to the right, but there's none up there. So if we look at that map file again, where the heck did my map file go? This is good enough. We know that face 1 is a boundary face, an open boundary. And I think I actually had one more time. I'm going to toggle back and forth a good bit, but this was your actual 30 box model with all the numbers. Here's your face 1 right here. So you see that you've got box 1, 2, and there's nothing up there. And that corresponds to face 1. We have 0, 0, 1, 2. So that's how boundary conditions are identified. And inside the code, that's how the code knows that face 1 is a boundary face.
But suppose you had a two-dimensional and you had a land cell. You know, you have a water cell adjacent to a land. It's not a boundary. You still have 2 zeros. So how does having 2 zeros?
Okay. Well, let's go down now to. Let me try to find one for you. Face 2. Boop, 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 boop. I'm gonna go back to the PowerPoint. Where's my PowerPoint? Lecture 1. Okay, so Jim, the way this works is this. Imagine this is the Susquehanna River right here.
Right.
So this flows downstream. There's no flow here.
Oh, so okay, just in the surface layers. How you,
Right.
Okay.
Yeah. Okay. I could have made this a 28 box model. Okay. There's no flow there. There's also no face, because there's no flow.
So when you come down to 11,
Now, the place where you get a headache, so there's no face right here.
okay.
So I don't need 2 zeros because there's no flow face to begin with.
So that's how you do it. Okay, thank you.
There's only a flow face if there's a flow.
Okay.
But since you're there, we want to look for something. Let's look at face 12. This one, okay? So we'll come back to, it's actually easier for me to go here. Now here's face 12. Let's look at the 4. You see you've got a 0 here.
Okay.
So the code knows, if you will, that for face 12, there's, box 11, but upstream of box 11 is a solid boundary.
Okay.
That 0 tells it that upstream of box 11 is a solid boundary.
Okay.
So, all right, so there you have it. So
Thank you.
if you've got the 2 zeros, you know it's an open boundary. And actually, the 0 can have 2 meanings, but let's go over it, because this stuff is really confusing and it took me a long time to understand it. So what you see is for face 2, for face 2, you've got one box to the left, which is box 1. And now you've got a boundary here, but there's a 0. So for face 2, it looks like, here's face 2, you've got
It's not there.
box 1, 2, 3, but you've got a 0 there.
Yeah. Okay.
So that's a key. That's really a key to identifying. Okay, there you have
What
it.
you're really doing is, as you said, and I didn't pick that up right away, but you're specifying the flow faces. And by not having one there, obviously you don't have.
There you go.
Okay. I'm still thinking in the IJK world.
Let's see, was there anything else I wanted? Before I leave this marvelous lecture 1. Okay. So yeah, I did want to make sure I covered, that map file. And again, you have to, if you work with CH3D, there's some software that sets it up. Somewhere, somebody, not me, has that software for EFDC, but in any event, keep conscious of the map file. So before we move on, last chance for questions. I see no faces, so okay, so we're going to close this one down and go to this one. Okay, yeah. I'll just mention, you should have, I believe I made available, I hope I did, these Word files. If you look at the creation dates, there's something like 2004, which tells you that they are from the original manual, and they're probably pretty good. On the other hand, there could be changes, but at the moment, that's the best documentation we have. So we have to go with it, and if I didn't give you those chapters individually, they are in that manual. I'm certain that the list of files that was available on the website included a manual, so they're in there you can take a look at the manual. And that said, let's move on. Lecture 2. Okay, so the magical file that runs the model is called the control file. And what the control file does is it specifies the parameters for the run you want to make, and it specifies all of the files that are going in and all of the files that are coming out. So it's the master file. And it's hardwired. It's called wqm_con.npt input. Don't change the name. You can change it to anything you want, but the model isn't going to run because in the code it's hardwired to look for wqm_con.npt. I suppose I should open that up. Change is coming to outlook.com. Look at that. Your thing is so slow that the bulletin I just got didn't show up over there. Anyway, we'll let that go. Okay, so here's a control file. We'll move that over. We'll bring this one, lecture 2. Okay, so this is your control file. This is the control file for that 30 box model. We're going to go over some of the key inputs for the control file and others we're going to ignore. A couple of things about the control file. Notice it is formatted. And most of the formats are F8, F8.0, F8.1, F8 point something. You'll also notice it has title lines in it. In retrospect, this is archaic. Remember again, this original code was 30 years ago. It was 30 years ago when we were limited to 72 characters. Actually, 80 characters fit on a, was the line length you were limited to. Okay, so that's life. So, Tom Cole, who did this, followed the convention at the time, which was, it's 80 characters. This is 80 characters long, and it's formatted. So keep that in mind. And the way this works is these titles right now are 8 characters apart. So you'll notice that all the numbers and all the fields and all the everything line up with those titles. You could do anything you want with these titles. You could put spaces in there. It doesn't matter. What really matters is the format statement that reads these is going to look for F8s. Okay, so it's not free formatted, and you got to obey the rules, guys. You have a couple of title lines up here. Tom gave us 6 title lines that you can use to describe your run, and these lines will be written at the head of the output. I don't know, I only found this worth 3 lines, so we got extra title lines. Again, these, you have to have all of these lines in there. If I said I'd only need 3 title lines, I don't need 6, I'll just put 3 in there. It's going to bomb, all right, because it's going to look for 6 title lines. So be meticulous.
You have a blank line after. Is that just so that you separate for presentation, or are those blank lines required?
Yeah, those are required.
No, they are, okay.
Yeah, the blanks that follow these are required.
Okay.
When Tom designed this, I don't want to, he had some rationale too, which was this is easy to read, right? Free format can be difficult to read, and he's got a blank between each line, so so it's easy to read. But on the other hand, I repeat myself, you got to obey the rules. So I think all this PowerPoint slide says is what I just told you, obey all rules, all right? So now, strictly speaking, in, let's see, where is that now? You can actually have 4 different kinds of grids in ICM. So, and you will be asked to specify, trying to find it over here. Let's see something. There it is. Okay. in that line, let's close that. Come back up. Okay. So if you're asked to specify here what kind of hydrodynamic model or what kind of hydrodynamic input you're using. If you specify binary, it's going to assume you have a three-dimensional Z-grid. And in the code, it's going to look for input from a three-dimensional Z-grid. You'll notice here it's specified as ASCII because the hydrodynamic input for our 30-box model is an ASCII. You know, for simple models, you can just enter the flows or enter whatever you need. I mean, that's how I do it. So ASCII is what we're using for our 30-box model. Depth average, which we won't talk about today, but is two-dimensional binary input. And it's CH3D run on a two-dimensional system, Delaware Inland Bays, Florida Bay, others. And last but not least is sigma. As it says, in the code, sigma is labeled as false. You know, if you want to run sigma, you need to go in and change that code. And this model is set up and will run with EFDC. I haven't done that in a long time, but it will. So for those of you who are burdened with running the EFDC simultaneously with the water quality, there is an out, you know what I mean? You can use EFDC the same way we use CH3D. So, and this is what I talked about before. Horizontal diffusion, I wasn't certain I had a slide about that, but the first application of the model was to a system with negligible horizontal dispersion. To minimize the size of the file, dispersion was specified once. The feature is still in place with binary or depth average. Spatially varying dispersion is a feature of the model code. Okay, what that means is, in the code, dispersion is separately identified at every single face, but you don't read it in for every face. What you do is you read it in once and assign it to all faces. So for those of you who want to have spatially varying dispersion, the facility is there, but you just have to figure out how to read it in for all the faces. Okay, so you can do it. And as I said, now that we're not worried about file sizes, now that we don't have, we could now make a variable dispersion in there if we wanted to do it, okay? And to use the ASCII option, I actually read in dispersion for all faces. I don't vary it, but I read it in for all faces. So if you use ASCII, it's easy enough. Okay.
I'm sorry, why would you have a scale factor for your vertical diffusion?
Oh, just for sensitivity runs.
Okay.
And that's something that Tom did.
Okay.
You know, it's interesting. The fellow who actually wrote this ICM code, before this he worked with a Corps of Engineer reservoir model called W2. And consequently, a lot of what you see here is just stuff Tom carried over from W2. So Jim asked, you know, what we saw previously was that there's, if you want to do some sensitivity runs with varying vertical diffusion, you can do it. I've never used this option, but it's in there, and I'm just going to say maybe it carried over from things that he did with the W2 model.